Hey everyone, I'm Gevorg Soghomonyan. I'm co-author of AIMStack. So AIMStack is an open source ecosystem of machine learning tools. We are mainly focused on building experiment tracking tools or machine learning metadata tools for researchers. So it's called AIM. It's open source, and we are it's being used in a good number of large companies. So I'm excited here today to share a little bit of the knowledge and insight that we have learned while working with many teams while building AIM, mainly around machine learning metadata and how to think about it. What's the role of machine learning metadata in ML infrastructure? And this rather strange name of my talk is an homage to a book, quite an influential book called Structure and Interpretation of Computer Programs. So in this talk, we are gonna talk about different versions of software, like software 1.0, software 2.0. We're gonna talk about ML systems as a representation of software 2.0. We're going to talk about machine learning metadata as a consequence of ML systems. We're going to talk about how the metadata is generated, how it's being used, and what's the metadata's impact over the ML systems going forward. And so hence the title of my talk, The Structure and Interpretation of Machine Learning Metadata. So we are going to hopefully quite comprehensively cover at a level we can do in 40 minutes. The machine learning metadata topic. So basically, what's the software 1.0, right? It has had its fair share of development. So 5 years ago, there was this famous stack called SMAC. So if you're aware, there used to be these different types of open source tools like Spark, Mesos, Akka was a a library that was for streaming, right? Cassandra and Kafka, and then as the software evolved, then it became SCAC stack. So another software 1.0 version where Mesos got replaced by Kubernetes. Essentially, this is a system, large-scale system that would allow you to build a pretty, software that could handle a ton of requests, a ton of data, in all sorts of ways. Obviously, nowadays people are doing data lakes, a bunch of different bigger data systems. But so software 1.0 has been evolving to with a certain pace. There has been other viewpoints. You can also build like relatively simpler software with, say, tools like the ones shown over there. So, however, since 5 to 6 years ago, this new notion of software have been evolving, which Andrej Karpathy kind of famously coined during, I think, a few years ago when he was sharing some of the stuff that they were building at NVIDIA as software 2.0. He even went as far as telling that software 2.0 is going to eat software 1.0. Rather controversial take, but a hot take. But yeah, essentially, and this is an image from his slide where basically he was talking about some of the machine learning systems that they have been building at Tesla to tackle the autonomous vehicle problem. So there are different hot takes about software 2.0. For instance, Hugging Face co-author and CEO Clem loves to say that the machine learning is the totally new way of building tech, as if machine learning is not built on top of software 1.0. But anyway, this notion of software 2.0 going to completely change the way we build tech is kind of establishing itself. And so basically software 2.0, what is software 2.0, right? So it's a set of software components that together, along with machine learning, it just comprises a different type of system that solves a problem that, for instance, software 1.0 couldn't solve, like recognizing images, making decision based on that, working with unstructured data like text, like audio, and essentially, basically these are systems mainly built around machine learning models and mainly built around building machine learning models. Because in order to use machine learning model, you need to be able to build those models. And so how do you organize all of these things? So income ML systems, right? Basically, the ML system has all sorts of different interpretations based on who you're talking to and the company you're talking to, the engineer you're talking to. So for instance, Metaflow, which is a pipeline tool out of Netflix, their kind of go-to pipeline is the following. You start your project, kind of get started with play with data, etc. And then essentially you go through different phases, right? You transform your data, you prepare your data set, then you train your model, then you test your model, and then you deploy your model. And then maybe repeat, yeah? So this is ML system version by Metaflow. There is another very famous person like Chip Huyen who loves to talk about real-time machine learning, which is, suppose you have built the model. Every time when you build the model, it has certain cost, right? You're going to have some GPUs that are going to use for your model. You're going to use those GPUs. It's not so cheap. And so how about we keep training model while the new data comes into our system? And so basically this is the real-time machine learning, right? And so they're building, I think at their company, they're building like streaming systems that are, basically their view of machine learning system is around continuously improving models without spending so much resources. And it's also the update time is, different than regular machine learning system nowadays where there is a batch versus streaming, right? So batch prediction versus stream prediction. And so it's a little bit of a different paradigm, right? And so this is another way of thinking about machine learning system. And then there is this famous diagram, right? Where the Google, basically this diagram created the whole MLOps industry. So everybody who have been building any type of ML at the time, like maybe 2016, so they had a certain level of pain, right? If you build machine learning systems, you understand, oh my God, this is totally different from what I was used to with software 1.0. Because I write the code, it's deterministic, and then I type something, it works. I type something, it works, right? And then with ML, it's different. Maybe you build a model, but then after you build the model, then what do I do with this? How do I update the model? How do I make this not make me waste my time, right? And so this diagram is a famous Google paper that kind of show, the code is just a small part of the machine learning infrastructure, unlike the software 1.0 where the code is almost everything, right? So yeah, so this, I'd say this all created the MLOps industry. So this is another view of machine learning systems or infrastructure. And this is a little bit of our modest take on pipeline. Obviously, we have taken out some of the bells and whistles of what modern machine learning infrastructure would have, such as feature stores, such as model stores. There is a lot more component to it. But at its core, machine learning system nowadays is like a type of a pipeline where basically you get your data and then you build a model and take it up until to production and hope it works, basically. And then even then if you're a little bit more advanced, maybe also monitor on the production. So, but practice shows that not many companies do it because it's just takes iterations, time. Things take time. So okay, so this is a typical ML system, right? A pipeline. And then once you start to go a little bit more advanced with your systems, the loops get to be introduced, right? So for instance, you want to make it easy to do the train pre-process loop. For instance, you have pre-processed a certain version of data, you want to train a model, and then, for instance, you took some of the results from the model, used some other way of pre-processing data and build a new model and then compare them, right? So different loops easily get introduced when actually trying to build more advanced machine learning systems. And more loops can be introduced. For instance, you have this promote layer. Once you build your model, you evaluate it, and then you need to decide whether to promote it to production, for instance. And so once you deploy it, and then once the data hits your model, maybe you want to revert back and bring up the other model that was there because this new model doesn't do well for real data, right? So for instance, data drift, the data drift metric doesn't show like good results. And so there are all sorts of loops that's possible to create inside the machine learning infrastructure. And so this is unlike any of the software 1.0 paradigms. And we can go even wilder stuff. There's all sorts of things can happen. Because you may not build one model, you may build several models that are interconnected, like a pipeline of models, right? So there is levels to machine learning infrastructure. Cool. So what's ML metadata? I guess one of the early easiest examples of machine learning metadata is basically when you track your training, right? So why do you track your training? Because building models is hard. Models are fairly stochastic, beings. And so once you're training your model, you cannot read the model, which is a set of numbers. You cannot read and say, oh, it's working. Or you cannot debug it. You cannot make any sense of those numbers like fairly, right? Unless it's a very small model. So therefore, you need to track a lot of information about the model. You need to track a lot of information about the training of that model. And so hence come the training tracking. And so not only that, but also training runs grow in numbers. So you easily end up running lots of training runs, which makes it even harder to understand which model to pick, how to understand which model to use, right? And it's very easy to waste GPUs, for instance. Every one of us does checkpoints, right? What if you have been what if you always go back to the previous checkpoints? So anything, basically anything trained by like that revert from the previous checkpoint is a wasted GPU. And the training runs at its core are multidimensional, which means they could have hundreds of parameters describing them. So it's a fairly large problem. If you have hundreds of this, then you basically need to figure out a way to compare them. So great. So okay, what is ML metadata? What is examples of it? So for instance, when it comes to experiments, there is lots of moving pieces. Basically, these moving pieces move all at the same time. It's not like sequential. So code changes all the time. You tweak one parameter, you run a new run. There you go, code changed. You tweak one parameter that's going to access a different data version, another change in data. Maybe you change a training environment. For instance, CUDA driver got updated, right? Model architecture, you decided to dump the previous architecture, now you're going to use new architecture. So hyperparameter tuning, which is a description of change by itself. So, and basically as a result, we get like thousands of training runs, hundreds of metrics per run, hundreds of hyperparameters per run. So this just introduced a large amount of dimensionality to just a small part of the process, which is just training the models. We're just talking about training the models and nothing else at this stage. So basically how you keep track of these changes, that's where ML metadata comes in. Basically this is all a description of a type of an ML metadata. So usually what we have seen people track in these types of scenarios, they track the hardware driver, basically track everything that moves in the system, hardware drivers, versions, packages, dependencies, GPU performance, node performance. There's, for instance, for GPU performance, there's I can bring 10 different metrics starting from temperature up until like the driver memory, all sorts of things you can track. We have seen people track stuff with data. So for instance, with data, right? When we are, for instance, talking about data preprocessing, in many cases these days, data preprocessing is another type of machine learning process. For instance, semi-supervised methods, right? So which means you run model over new data, generate new data, etc. But which generates new versions, generates basically new sources of data, new samples, new annotations, right? And the code obviously changes as well. And then apart from this, you end up tracking a lot of information about your model, which is images, metrics, hyperparameters, text, whatever is your problem. So this is just still the training tracking. So what is ML metadata? So training tracking actually gives a decent idea what ML metadata is, because at every point in the pipeline that I've showed, similar type of data gets tracked, right? So at pre-processing, as I just mentioned, you may end up easily tracking very similar type of metrics, versions of the data. Why? Because you need to have an idea, for instance, how your synthetic data generation works, so that it's somehow connected to your training, and then evaluation is another set of metrics you're going to track. Up until the production monitoring, you still track lots of metrics. Basically, you try to track as much information as possible about anything ML to make sense of things. Sometimes locally, like training, and sometimes end-to-end, because these things are costly, so you want to be on top of them. So basically, ML metadata, it could be of two types, like dictionaries. So dictionaries are things that describe the dimensions of your, for instance, machine learning training. Like your hyperparameters are an example of that. Your data version are an example of that. Your, for instance, your system environment, parameters are a version of that. And so it also describes the differences between, these different, like training runs, or the evaluation runs, or the pre-processing runs, right? And then the sequences is basically the metrics and the sequences of images, right? So basically, roughly, there are kind of two types of things you could track in the machine learning infrastructure as a metadata. That fairly describes your processes. So how people use ML metadata currently? So obviously, we've talked about training tracking, which is model debugging mainly. It's being used for comparing lots of these training runs. So comparing training runs is one heavy application of metadata, like a very instant application of machine learning metadata, where researchers daily need to do that. But it's just only part of it. Production monitoring. Now there is, like, I don't know, 10 companies that are just doing data drift, a type of a data drift, right, out there. Fiddler AI, Amplitude, evidently, yeah. So just number of them, open source, closed source. So it's another type of hot problem. Model evaluation, like Gantry, this loops are being built, right? There's also, a lot of development on this area. So these are all type of machine learning metadata currently being used by different companies. So what's the difference basically? So somebody could ask a very valid question of, okay, great. So you're talking about this machine learning metadata thing, but we have been tracking like software for ages. Like we have production logs. We have been, basically, why is it different? Why machine learning metadata is different from like software 1.0 logs, right? So there's a bunch of different tools out there, like Prometheus, Datadog, your terminal, right? So these are all tools you could use to track stuff. So the fundamental difference is that, so what does it mean to build software 1.0? What does it mean to build software 2.0? So when you're building software 1.0, it's a deterministic process where it's not like a black box. You expect to write code, and then you expect it to work in a certain way, and then you repeat, right? And usually people log and try to log everything possible about the software 1.0 when it hits the production, so that they don't expect things to not work, and so they try to log so that whenever it doesn't work, they could go back and understand why and kind of fix it and keep expecting that it will work, basically, right? So that's one of the main functions of tracking stuff for like software 1.0 in production. And essentially, most importantly, the development cycle in software 1.0 is oriented around the code. Basically, the code is source of the truth for software 1.0. The development is determined, and the most important, their tools are basically the IDs and all sorts of virtual environments and like these types of tools. And most expensive infrastructure actually goes to production. So people don't build on there, like unless in specific circumstances. Usually, the most expensive metal hardware goes for production, for scalability, and all obvious reasons. So they try to track everything on production. And so what does the ML metadata mean in this context, right? So there are different tools that track machine learning metadata in many different contexts. So again, the difference is the building ML, right? Building ML, so machine learning by itself, by nature, is a non-deterministic thing, where you write the code, and then you are not sure if it will work, actually. That's at the core, right? And then there's many ways it cannot not work. Math may not be done right. Maybe there is a bug. For instance, if you have an issue at software 1.0, it's going to throw an error, or maybe the output won't be right. If you, for instance, use a matrix in machine learning model and then somehow accidentally transpose that, like a square matrix, and just use the transpose of that matrix accidentally in your code, you're screwed. Like it's going to be hard time. Like no error is going to be thrown, none of that. So how do you know if you have, I don't know, a typo, right? A square matrix and the transpose of it. So the issues don't happen like naturally in basically software 2.0. And so therefore, like, you need to figure out a way to gather the insights about your process, right? How do you know if like things are not looking right? So therefore, in the process, it's a insight-oriented decision making. It's not like a white box or input, output, right? Errors thrown, warnings thrown. And basically, what it makes ML metadata is a development tool, actually, as opposed to just a log. Right, because it's literally what you work with, because it's what you have anyway. This is what you only can use to understand what's going on with your model while building the model. Yeah, and so basically code and data alone do not produce the good models. It's the math, it's the researcher looking at the metadata, it's all of them together. And so, to bring another parallel, the most expensive infrastructure is actually used for development for machine learning. Because I don't know if you have heard, GPUs are not cheap. So basically what things you can do with ML metadata, now that we have established that ML metadata has a role in machine learning development, a little bit more advanced than in software, these types of logs have in software 1.0, what can you do with machine learning metadata? So for instance, and now that we are talking about this wider sense of machine learning systems, we can use machine learning metadata to visualize AI pipelines, right? Because it's generated basically all across the machine learning pipeline. We can connect different tools together. We can use it for governance. What is a governance? You want to see how you started to build your model up until production and backwards. That's what, so the whole way. And then you want to have basically this whole tree of things you have done. It's also known as lineage. Also, and reproducibility. You want to easily connect your metadata view to the pipeline tools, to the resource tools that would allow you to reproduce the same run you have had while training a previous version of your model. And the compute efficiency, there is all sorts of ways you can make your GPUs not be wasted. Heuristics over, like, oh, when the metrics become XYZ, stop the training, change the hyperparameter, etc. You can obviously make your model perform better. You can actually define new metadata types to help that even further. So suppose you're a computer vision researcher, and for instance, you're tracking you're solving a problem where you like webcam like computer vision problem where it wants to say which direction of your eyes are looking at for some reason, right? Like in order to really understand your model, you need to maybe track like a specific type of images where like you see your angle of your eye, because maybe that would be the stuff that you're tracking for your specific problem. And so these are new types of metadata that's not a metric, that's not a regular image, that's not a text. So new things may need to make, you may need to have to make analysis or like just make better models faster. And so obviously integration with pipeline and compute tools, and a compute tool would be, for instance, a Kubernetes or a Slarm. How do you, because these compute tools, they represent the environment, which also could change during different runs of your training. So These all generate machine learning metadata. And so this shows basically that machine learning metadata is the glue for the machine learning infrastructure, which means it's this thing that connects different tools together, right? If you have a hyperparameter tuning tool that you want to connect with your data preprocessing tool, one of the ways to understand how your data came in and this model got selected is basically look at the machine learning metadata in different formats. And I was supposed to have a visualization here where these gaps are filled by gray something that's the metadata, but yeah, I imagine that's the one. Yeah, and so basically all these complex systems are to be connected with machine learning metadata, and so this is the kind of interpretation of machine learning metadata in ML systems. And so machine learning metadata love ML systems. Basically, is generated everywhere. They're all connected with each other. All these different metadata. Why? Because you want to keep track of things as much as possible. Because while building ML, you spend your most expensive infrastructure. And it's a development tool for machine learning, from data pre-processing to model deployment. Machine learning systems are stochastic and non-deterministic, which means that you need to track everything that moves. And so the way machine learning systems could be going forward is, there is a stack of tools connected by machine learning metadata. So at the bottom, there is frameworks, then there is resource managers where you Slarm, Kubernetes, Ray, PyTorch, Lightning, everything that helps you deal with the number of GPUs or CPUs in that matter. So pipeline management tools like Metaflow, Flight, Airflow, feature stores, model stores, production packaging and acceleration tools, and machine learning metadata that just connects these together. And so this is our hot take for machine learning systems in the future. And I'm happy to take in some questions. Thank you very much. Thank you very much.